Good morning. All right, what we're going to look at today is difference of squares. And basically, you can get the same answer by just distributing, doing the FOIL method, distributing first term to the, let's look at this one, by just distributing x times x squared, x times -4 is -4x, and then take the second term. 4 times x is plus 4x, and 4 times -4 is -16. Distributing, or as they call it, the FOIL method. Combine your like terms, and you get x squared. -4x plus 4x cancels out, and then minus 16. All right, so it's basically the answer you get when you distribute. However, when you notice this type of problem, you can see that it's a difference of squares. All right, so this is difference means subtracting, right? And if you notice, x squared is a perfect square, x times x, and 16 is a perfect square, 4 times 4. And it has to be a difference. They have to be subtracting. So if you have one like this, and we said to factor this simplified form and put it in factored form, then all you're going to do is take the square root of this minus the square root of this, and then you're going to say the square root of this plus the square root of this. Okay? So look at this one. You got 5m and 5m. So plus 1 and minus 1. So if you take 5m times 5m, you square it, you get 25m squared. Put your minus sign, and then the square root, the square of 1 is 1. So let's see if that works. 5m times 5m is 25m squared. 5m times -1 is minus 5m. 1 times 5m is plus 5m, and 1 times -1 is -1. These cancel out each other, and you're left with 25m squared minus 1. All right, so these are called the difference of squares. All right, so this one would be 2a squared is 4a squared, and then put your minus sign, and then 3b squared would be 9b squared. All right, test it out. 4a squared, and then that would be minus 6ab. This would be plus 6ab, and then this would be minus 9b squared. These cancel out, and you're left with that. All right, so the rule is, first make sure you have an actual difference of squares. It must be a subtraction, must be a subtraction sign, and you take the square root of both terms. So a squared minus b squared is your factor rule. So that would equal a minus b and a plus b. Okay? And you can check it by just distributing. So first off, we have a minus, so we're good there. And then the first term is a perfect square, a times a, and the second term is a perfect square, 2 times 2. So my factored form, one of them's going to be plus and one's going to be minus. So the square root of that is a, and the square root of 4 is 2. All right, you can test it. A times a is a squared. A times -2a is -2a. A times, 2 times a is positive 2a, and then 2 times -2 is -4. These cancel out, and you're left with that. All right, so it's subtracting. You have n is a perfect square, 64 is a perfect square. So one's going to be plus, one's going to be minus, and square root of n squared is n. Square root of 64 is 8. Perfect square, perfect square. One's plus, one's minus. So square root of 81 is 9. Square root of x squared is x. Simple, right? This is just a shortcut. When you see these type of simplified expressions, you can put it in factored form by using this rule, okay? C squared, square root is c, 100, square root is 10. Okay, all right, look at this one. First thing you look at, is this subtraction? No, it's a plus, so this one's prime. I can't do that on there. Okay, it's already simplified. All right, this one is minus. Are they both perfect squares? Yes, they are. So it would be one's plus, one's minus. Square root of 1 is 1. Square root of 49y squared is 7y. Well, 7y times 7y is 49y squared. All right, let's look at number 21. It says look for a GCF first. And remember when I was talking about GCF on the video, talking about that was our first step in factoring. You always, 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 in any type of problem, if you're asked to put it in factored form, you always, always look first if there's see if there's a greatest common factor. All right, do that first, and then factor it on down to factored form. All right, so what's your GCF for this? Be 2. So it'd be 2n squared minus 36. All right, so this is a difference of squares, right? So we could factor that on down to a plus and a minus. Square root of n squared is n. Square root of 36 is 6. So now this, including the 2, is my factored form, my answer in factored form. All right, 18 and 50. Okay, do I have a GCF on that? Well, it's not 5. 3 won't go into it, but I can do 2. So it'd be 2 times 9x squared minus 25. All right, so I'm not done factoring. I can factor this now. So bring your 2 down, and that's a difference of squares, because I have a minus sign and 2 perfect squares. So it's going to be 3x plus 5 and 3x minus 5. All right, let's look number 23. GCF for 18 and 32. Let's see, 6 won't, 9 won't, but 2 will. All right, my variables, I got a S and a U, so nothing's common there. So this would be 2 times 16 S squared minus 9U squared. So now I've got a difference of perfect squares, okay? So I can bring the 2 down, and then I'm going to have 2 binomials. Square root of 16s squared is 4s. I'm going to do a plus and a minus. Square root of 9u squared is 3u. Okay, So I can't factor anymore, so that's my factored form. All right, number 25. Do I have a common factor? Let's see. 24, 8. Think of the factors of 24. 12 won't go into there. 24 won't go in there. 8 won't go in there. 6 will go into 24. It'll also go into 54. So let's do 6. And we don't have any common variables. So divide each term by 6. So you have 4a squared minus 9b squared. Sorry, y'all, my voice is going out. All right, so bring your 6 down, and this is a difference of perfect squares. So we're going to have 2 binomials. One's going to be plus, one's going to be minus. Take the square root, so that'd be 2a as your first term, and then the square root of 9b is going to be your second term, 3b. So now this is my factored form. All right, number 27. Both of them end in 0 or 5, so I'm going to say 5. Because 25 won't do. This would be, it's not 40, okay, so 5. And then I do have ends. Ends are common, and my smallest exponent's 2, so n squared would be a common factor. So now I'm going to divide each term by 5n squared. 5 will go into 80, 16 times. N to the 4th divided by n squared is n squared. Minus 125 divided by 5 is 25. And then n squared divided by n squared, they cancel out. It's n 0, which anything to the 0 power is 1, and 1 times 25 is 25. All right, so they cancel each other out. All right, so I'm going to bring this down. This is difference of squares. So it'll be 2 binomials, one's plus, one's minus. And your first term is going to be the square root of 16n squared, which is 4n. And then your second term will be the square root of 25, which is 5. So there's your answer. I got 2 more. So 36 and 9. Well, we know 9 will go into 36, so 9. And then p and p cubed. My smallest exponent's p1. So now divide by 9p. So it would be 4p squared minus 9p will go into 9p one time, right? You say, well, wait a minute, what is that? Well, it's a difference of square, because square root of 1 is 1, right? So we can do this. So 9p times 2 binomials, one's plus, one minus. So first term, square root of 4p squared is 2p. And then the square root of 1 is 1. So you have a factored form there. And our last one here, 16 and 100. Well, we know 2 will go in there. Let's see if it's going to, since it's 16 and 0, it's going to be even. Can we do 2, 4? 4 will go into 16, 4 will go into 100. Can we do 6? No. 8? But 8 won't go into 100 evenly. So let's do 4. We'll see if that's going to suffice. K is common. My smallest exponent's 1. So this would be 4k squared minus 25. K's cancel out. So you have a difference of perfect squares. So it's going to be 2k minus 5 and 2k plus 5. So this is going to be our factored. Now let me show you something. What if we didn't see that 4 was a factor? We just did 2. So what if I did 2 times, let's do 2k. 2k times be 8k squared minus 50. Well, I'll say, uh-oh, 2 will go into 8 and 2 will go into 50, right? So that's common. So what I can do is, instead of redoing, just say 2 times 2, and that's 4k. So you're going to use 4k instead of 2k. All right, so when you get through factoring, like when you get to this step here, always make sure that it doesn't have a greatest common factor again, just in case you missed the greatest common factor. All right, sometimes you'll pick like 2 or 4, and since it was bigger numbers, you overlooked that it might have been 16. So you use 2, and then when you factor it out, you're like, whoops, 8's a common factor. 2 times 8 is 16. All right, so always make sure, check your answers for greatest common factors. All right, so this is a pretty simple lesson, and like I said, even if you didn't know how you could factor it another way, and we'll get into that tomorrow. Well, the next lesson will be on factoring without one of the special things. This doesn't happen all the time. It's just when you have a difference of perfect squares. Okay, it's just a little shortcut. All right.